Hi everyone. In this video, I'd like to do some simulation to demonstrate to you why we need to do power factor correction. What are the advantages that we will gain when we have power factor correction? So basically, we have our loads are inductive. So they consume both active and reactive power. Okay? Now, when we connect the capacitor bank here in parallel, locally, I will be providing part of the reactive power. So what will happen as a result of that? As a result, the energy or the total power needed from the supply will be reduced by this amount of QC. So the reactive power needed from the system will be less. And hence, the total S will be less in the system. And this is what we said, freeing up of the available energy. The current here in the line will be reduced. And hence, the losses in the overhead lines or in the underground cables will be also reduced. Also, the voltage drop here will be reduced as well. So these are some of the most important advantages when we connect the capacitor bank. So now let me show you a demonstration here using the automation studio, the advantages of connecting the capacitor bank. So basically, I have an RL load, single phase. The whole thing is single phase, but you can apply to three phase as well. And this load, if you double click on it, it has 500 total volt amp with the 350 var. Okay, so that is the total Q of the system. So it's highly inductive. I connect here to the load the power factor to measure the power factor before and after adding the capacitor bank. Here is the capacitor bank, and if you double click on it, it provides 100 var. So part of this reactive power will be coming from the locally. Then I modeled the line between the supply, which is 120 volt, low voltage, with a resistance in series with an inductor. And I will measure the voltage across this transmission line to see, or distribution line to see what is the voltage drop. I will measure the power loss across this line, and I will measure the reactive power at the sending end. Okay, so let's start the simulation. So when you start the simulation here, you can see here the power factor is 0.735 lagging, so the power factor is pretty low. The voltage drop across the line is 29.3 volt, and the power loss is 56.2 watt. The var that is produced here is 260.7 var. Now, watch what will happen to all these numbers the moment I connect the switch. Power factor has increased from 0.735 to 0.85. The voltage drop has dropped from 29.3 to 28.3. So this voltage drop. The power loss was 56.2 watt, now has been reduced to 52.5 watt. And more importantly, the amount of reactive power, it used to be 260.7 coming from the supply to supply the whole system. When we connect the capacitor bank, has been reduced to 212. And also you can see that the line current has dropped from 3.08 amps to 2.97 amps. So overall, you can see here a very good improvement in the system in all aspects. And this is why we connect the capacitor bank in the power system.